I'd like to talk about what's known as a logistic growth model. A logistic function or a logistic growth model is a function in the form f of t equals c divided by 1 plus a times e raised to the minus bt power. A, b, and c are constants. C and b are bigger than 0. I want to talk just a little bit about what this graph would look like. If we plug in t equals 0, then e raised to the 0 is 1, so I get c divided by 1 plus a. Well, that's just some constant, which tells me I'll have a y-intercept, right? And I could actually write that as c over 1 plus a, but I just wanted to make sure I had a y-intercept of some kind. Okay, now let's just look and talk for a moment about this part. If I just thought about y equals e to the bt, well, that's an exponential function. And because I have that negative in the exponent, and because b was positive, I know that's actually a negative in the exponent. I know that is a exponential decay function itself. So as t goes off to infinity, I know that this gets closer and closer to the x-axis. So when t gets really, really big, this part that I've dotted in blue goes to 0. Right? It gets closer and closer to being 0, which means a times that is closer and closer to being 0, which means when t gets really, really big, this fraction is getting closer and closer to c over 1. So that tells me the largest this fraction can ever be is just underneath of c, because this never actually gets to 0. And if we were to plug in a whole lot of points, we'd see a function that grew quickly to start with and then started to level off. And this is the shape of a logistic growth model. It's an example of what we call a limited growth model. Logistic functions are great for modeling things like populations. Populations of people, or if you were even thinking about bacteria in a petri dish. There's a limited amount of room in the petri dish, which means the bacteria might grow quickly at first, but they have to level off. And this is that thing you might have heard about in a biology class called a carrying capacity. So logistic growth models are always examples of limited growth models. And if we write it down in this format where we have c divided by 1 plus a, e to the minus bt, then the limiting value is c.